Righty tighty. Hey folks, thanks for joining us again today. Um, as you know, I've been super excited about today because we finally got the horse's mouth, so to speak. He's right here, and it's his model. This is effectively like Plan B of stock to flow. This is Giovanni of Bitcoin Power Law. So Giovanni, thank you so much for joining us.
Yeah, sorry, I'm just in the camera. Oh, okay, perfect. Yeah, my pleasure. It is my pleasure.
As I explained just before people jumped on, everyone here today has sort of seen the idiot's version of the power law from me.
No, I saw the slides. They are nice. They are very nice slides.
Thank
It
you.
was not. It's one of the best presentations
Oh,
I've ever
oh
seen.
well. Yeah, I've probably seen
Very,
about
very
4 hours of your videos and about 10 hours of Jeffrey West's from from 10 years ago and whatnot.
good.
But the problem is, and I think what most people are struggling with is, oops, there we go. Sorry, I'm going to mute everyone again. Right, mute all. Asked to unmute Giovanni. Right, here we go. Yeah, so I guess the problem that I'm personally facing is that I can watch as many videos about this as possible, but because I have zero scientific background and I'm just an idiot with maths and science, there will always be this glass ceiling and a level of knowledge that I just won't be able to penetrate. Whereas for you, this is, like as you said in one of your videos, a log-log plot is very basic for a physicist. You guys deal with them all the
Mhm.
time, but for us, seeing a log chart or log plot and seeing time affect, or it looks like it's bunched up at the end, that's, to me, that was quite alien. And so, and I've seen a lot of your videos where I guess you're touching on a lot of the same stuff, and I don't want to waste your time and waste this opportunity. So I want to try and dive and ask the questions that people haven't really asked before. So obviously there will be some similarities. So the first one I have is, have you ever seen a situation where something has adhered to the power law but then suddenly departed from it?
Yeah, it's actually relatively common in the sense that so these systems behave in this way, right? Because it's basically what is called so there are key concepts when we talk about power laws. One of the most important is this idea of scaling that I explained many times, right? It's basically you're trying to focus on how the system changes over, it could be over time, it could be over some other parameters, but basically there is a relationship between two quantities. And when you look at it in the right way, so this is why we plotted in a log-log chart, because what the log does, it's extracting the power. So power means, if you think about a number with a scientific notation, right? So instead of thinking about a number as 10, you're thinking as 10 to the 1, right? And then 100 is 10 to the 2, 1,000 is 10 to the 3, right? So it's basically that number, the exponent, is called the power, right? So you're raising 10 to the 1 to the power of 1, you're raising 10 to the power of 2, and so on. So if you focus on the scale, and why the scale? Because you think about something that grows a lot, right? Some kind of process that goes from being a small thing to a huge thing. Like it could be a city, right? A city that starts with only few thousand people, and then within a century maybe goes to 1 million people, right? A century is a long time for a person, but for a city it's not, right? And then if it changes so many scales, if you plot it in a linear plot, it will look like nothing happens, right? And then it's not an exponential growth, it's a power. So you will have to raise it to some kind of constant, right? Some kind of value, the power. And so it looks very fast. Uh, and But at the beginning, nothing happens, and then it looks like a lot of things are happening behind. But if you plot it in a log-log plot, it will look like a straight line. And what is the significance of a straight line? The straight line means the process when looked in the right way. In this case, if you focus on the scale, so how the system went from 10 to 100 to 1,000 to 10,000, then it's consistent, then is constant in a certain sense, right? Because it's changing, but the rate of change, again, when you focus on the change in scale instead of a change in the units, the normal units that you're measuring, it's regular, it's consistent, right? Because this is what a straight line is. It's a change that has a consistent rate of change. And so that is significant because it means, first of all, that we call it scale invariant. So it means that the change that we are focusing on, again, emphasizing the scale of a system, it's not changing over time. So when the system was small, it was behaving in a very similar way to when it was in its middle growth and when it was very large. So it's scale invariant means it does the same thing at any different scale. And there are a lot of different consequences about this behavior that are very interesting, because it's something that is now common, right, in terms of our experience, but it's something that is common in nature, happen many times with many different systems. And there are reasons because as a physicist, when we observe these power laws, for us is a way also to get a clue about the processes that are behind. Usually this means, so these power laws are created by interactions of many different forces that come together. And these interactions are non-linear. They are multiplicative. That means if you have a small change somewhere, you can get a big reaction somewhere else because it's not about adding them up, it's multiply them. So there are a lot of interesting things that you can learn by just drawing this power law. And to answer your question about a system behaving in a power law fashion and then changing, it happens because so one of the things that we observe often is that the system goes through what is called a phase transition. So it behaves in a certain way for some time. In fact, it could be continue to behave like a power law, but what changes is the slope of a power law. So it's not just about drawing a line where, like I say, there is a lot of information on that line. For example, the slope itself, the value of the slope itself is the power of a power law. It turns out that it's, if I have a relationship y equal x to the n, and you plot it in a log-log plot, the n becomes the slope of that straight line. It's a very simple math to show this is the case. But by doing regression, right, you will get some parameters about the regression. Regression means you have these points that not necessarily, they kind of look like in a straight line, but you still have to do some kind of mathematical operation to fit a straight line. So that fitting means you're trying to find the best line that goes through this point. So you're minimizing the distance of a point from the line. And then when you do this operation of fitting, you get parameters. And one of the parameters you get is the slope of a straight line. And that slope sometimes can change, sometimes even abruptly, because what happens, the system goes through a phase transition. So it's possible, that typical phase transitions are things when you have a system that is in a particular state. The example that we use often is water, right? So we know water goes through different, as three different states, right? It can be solid in the form of ice, it can be liquid, right? Like normal water, and then it can be a gas in the form of a vapor, right? It's like when you have steam. And so it's still water. It's water when it's ice, when it is liquid water, when it's steam. But the behavior of this system in these three different states is very different, right? Everybody is familiar with it. The property of ice are not similar to the property of water. So if I try to describe ice with the same equations that I describe water, it will fail, right? It becomes something, it behaves in a very different way. And so, and in this case, we're not talking necessarily about a power law. I was just using water as an example of how a system can change state. It can be the same thing, but when it changes states, it's behaving very differently. So in the case of power law, you have something similar where you go through these phase transitions. It could be something where maybe the system has reached some critical mass. It has reached some critical temperature or whatever. And then once that threshold is reached, the system continues to behave in a similar fashion in terms of being a power law, but the slope will change. So that can happen. Usually there is a reason. And so, for example, in the case of Bitcoin, if we see, so this is what one of the things that they say all the time. First of all, it behaved in this way for 15 years. So it needs to be understood. It needs to be explained because it's not by chance you're going to get a behavior like this, like the one that we are showing right now in the chart. It's possible that we could see a phase transition, right? So now the slope becomes much faster. It means steeper. So the growth will be faster, or it can slow down. It's not something that can be excluded. The interesting thing about the utility of a model is that if that happens, then we can see, right? We will be able to compare it with what happens next, and then we will be aware that something very interesting has happened. Now, the other thing that comes with that, so it is possible. At the same time, it's very unlikely when a system has done this, for example, for 15 years, that they will some dramatic change will happen afterwards. Because usually the other things that we associate with the idea of these power laws is that the system is very resilient. It's anti-fragile. It's, it can respond to stress. Like, for example, one indication that the system will continue to do the same is these bubbles. So look at these bubbles. So the bubbles can be understood. That is how a physicist will think about them as some kind of stress, some kind of external force that happens in the system. Like, when you have, for example, a spring, right? You have a spring, you have a mass attached to a spring. It's a model that we study often in physics because it's a simple toy model for things that are oscillatory. So if you have a system like that, you kick the mass attached to the spring, what will happen is that the system starts to oscillate. But if you start it at rest, it wants to go back eventually to rest. Or if it oscillates, it will oscillate around this point where it started, right? So it goes back and forth, back and forth. And so this is what happens here. This is how I will think as a physicist about this system, that you see the general trend is actually pretty well captured by this range, right? A green band. So what is, I'm sure you explained to your viewers about this chart, but let me summarize it a little bit, right? So first of all, what we observe here is the log, right? So you can see that we have a log of the prices on the y-axis, right? So you can see this scientific notation where you have 10 to the 0, 10 to the 1, 10 to the 2. Some people are not familiar with this notation, but it's really simple, right? All what it means is that you're taking the power of 10, the power of 2, and so on, right? And then the more unusual thing for most people, we are taking the log of time. In this case, is log of days from the Genesis block, right? That is January 3rd, 2009. So this is when Bitcoin was created. And so you take the days. You can do it with months. You can do it with anything. The days are is a useful quantity to measure time in this case. And then we express, because it's nice to see dates, we express this time in terms of dates, right? So if you have days, then you can convert them into dates. But basically is the time that has passed since Bitcoin was created, and is a relevant if you're measuring, if you're trying to think about this as a system that changes in size, you want to know how it changed from the time it was born, right? And the reason why we don't have earlier data here, DNC starts something like in 2010, is because this when the first markets start to open, the first exchanges, right? Mt. Gox historically was one of the first exchanges to open. And the usefulness of using exchange data is that it's very objective, right? That is what Bitcoin was traded for. Before that, we do have some transactions. Everybody's familiar with the pizza exchange, right? When somebody bought two pizza for thousands of Bitcoins. And then there were a couple of others that I was able to find online. But because they are sporadic, etc., I didn't include it in the calculation. Now, I did eventually go back and I kind of extrapolated the curve in the past. And strangely enough, at least two or three of these points follow the trend. And the only exception is the pizza. The pizza actually was a bad deal even at that time. It's not just a matter of Bitcoin was worth very little. No, the guy could have got much more pizza, but it's okay. It's interesting. But anyway, so we have dates here. We have the log of price. I know it sounds weird because it looks like the time is bunching up here, but all what this means is that basically, for the system to change, it takes longer and longer time, right? So if you see these with, if your sensation of time was tuned to logs, it will look linear to you. And I do this example all the time. I say, well, we are not completely unfamiliar with this log transformation in terms of experience, because, for example, our sense of hearing and our sense of sight, it's actually working exactly the same fashion. It works in a log fashion. When you go outside from your room, the intensity of light changes by many thousands. But to you, it looks brighter, but not thousands of times brighter, because otherwise your nervous system will be overwhelmed. It looks like maybe two times, three times. And that is because we are sensitive to the change in logs of a light. Evolution somehow compensated, for this very huge range of intensity of light that we are exposed, in our life, by tuning the system to be sensitive to changes in power, right? Instead of changes in linearly. And so we are not aware of that, because unless, you do some experiments and you test it, you don't know. But that is exactly what happens with our sense of sight. And the same thing happens with the sense of hearing. We're exposed in our life to a huge, bigger range of possible sound intensities. And, we will be very overwhelmed, and our nervous system will not know how to handle this huge range unless, the scaling of how we react to these changes in intensity is tuned to be a log change. So we are not completely unfamiliar. It's something that we do all the time. It's just that time, the sensation of time is linear for us, because we live relatively short lives, and we perceive time linearly. If we lived probably, it's interesting idea, right? If we lived like mountains live, right, millions of years instead of a few years, it's possible that maybe we develop a sensation of time that was also log. It's an interesting idea to think about. Maybe there are some beings over there that live millions of years that have a sensation of time that is a log sensation of time instead of being linear. It's interesting.
That's so do you mind if I just go?
But Bitcoin is such. If you think about Bitcoin as a living thing, Bitcoin time, this is why I love this approach, because it becomes a philosophy, right? So one of the things that you think, Bitcoin time is log time. it is this weird creature that works with this different type of time where as it scales, is going to take his own time, right? So when it goes up every time by a factor of 10, it's the same thing for it because he's from the Bitcoin point of view, is perceiving time in a log fashion. And so when you do that, when you transform time, so this is called a transformation, when you transform time into a log, right? So you take a log of time, then everything looks linear. So to me, when I saw this picture the first time, I stare at the screen for few minutes because I thought maybe I did a mistake. There is a bug in my code or something? Because it looked so weird that an asset will behave in this very regular fashion, right? It's something that is striking because this is why we do this transformation, because we like lines, right? Human beings are we recognize line very easily, and it looks straight, it looks linearized, right? Now, there are these bumps. Yes, there are the bumps, but in general, it's a straight line. And I know that we started to talk about, changes in slope, etc. So like I was saying before, just to finish my thoughts, sorry if I did this long parenthesis, but so if you stress the system, right, you see how the system seems to go what these colors represents, these are deviation from the general trend. So if you think about this line being the general trend, that is the line in the middle, the band represents like, it's described in the legend on the side, represents deviation, right? So the negative deviations, if you go to yellow and green, because it means you're below the trend, and positive deviations if you look at the pink and red, because you're above the trend. And so if you look at the green line, the green band, it seems that what we call the bear market are actually pretty well represented by this band, right? In the sense that there are, again, some oscillations because the process is still, in general, the process is still random, right, locally, but even with that randomness is still contained by these green bands pretty well, right? Yeah, almost amazingly well. And even when we are in a bear market, we are still going up, and we are going up in a very predictable fashion, as this chart shows, right? There are some exceptions, here during after the peak in 2018, right? We had like, the system didn't go all the way down here to the green line until later, then it went up. But again, it was kind of close to that. And then, with the recent bear market, it followed almost perfectly this confinement in this green band, right? So the green band seems to represent very well the behavior during the bear markets. And then during these bull markets that usually happen during the halving, so here the asterisk represent the halving. Now there is this big bubble before the halving, and we should study this and see what happened there. Some people say that it was like artificially created by Mt. Gox, etc. But we cannot, we need to understand what happens there. But if we focus on the ones that are associated with the halvings, they usually happen just after the halving, right? And not immediately, but there is some waiting time, and then all of a sudden the market starts to go up, it reaches a peak, and then it goes down, right? And so it's almost like a disturbance that happens, right, in the force. If you think about it like Star Trek, right? So there is this force that keeps going, and then there are these disturbances, there are these oscillations, and so the system is perturbed. It's another word that we use in physics. There is a perturbation of a system, and the system reacts to it, and that is another property of systems like power laws. They react to these changes very dramatically, but then they have the ability to go back to their original state, right? So it's like think about physiology. So physiologies are also driven by power laws, right? We have a lot of graphs that show how metabolic rate and other processes in physiology are regulated by these power laws. there is this principle of homeostasis, right, in physiology, where if you perturb a human being, biological entity, it can happen. Your heart rate can go very fast up, but then it wants to go back to its original state. That is called homeostasis. So the system wants to go back to equilibrium. And so the same thing happens here, where after this perturbation, the system wants to go back to equilibrium. So that is another evidence that this thing that Bitcoin is doing for 15 years will continue to happen. I will be very surprised. And like I say, it's not impossible, but it will mean something dramatic happen to Bitcoin, and it will need to be understood. So the utility and the usefulness of this model is also to show if something happens, that it happened, because we can compare it with the previous behavior, and then it will allow us to see also what happened, how it changed. Did it go faster? Did it go slower? Did it continue to be a power law? But in general, my bet will be on the system to continue to do what has done, because it has gone through a lot of perturbations already, and it always responded in the same way. That was to go back to its general trend. So this is why and sorry, and then I will let you ask your question, but let me finish my thought. This is why when people ask me, what about this? What about that? What about China banning Bitcoin? What about Biden banning mining? What about the ETF? It's all included. It's all included. Bans from China happen all over the history of Bitcoin. It's not the first time. And yes, locally that will mean maybe there is a drop in price, but then the price goes back to its original trend. And so Bitcoin went through a lot of the things that seem to create the biggest changes in Bitcoin temporarily are these halvings. But even the halvings, that is a very dramatic change, right? That it's pertinent to Bitcoin itself, because of the amount of coins that are produced goes by half. This is why the system reacts so violently to that change, but eventually goes back to its original trend. So, that is one of the biggest shocks that you can produce to the system. It goes back to the original trend. So the ETF is simply another event, it's almost like, actually, you could say the other way around. You could say, because Bitcoin has this particular growth pattern, has been so stable, and it grows up and go up, doesn't matter what, it cannot kill it, then it attracts resources, right? It's probably more like a feedback loop, because this feedback loop was there even when Bitcoin didn't have a value, right? It had a theoretical value. It was interesting. It was fascinating. People started to understand it. The few people that were involved in the beginning, they put their resource into it, their time. Some of them were running the computer, so spending electricity to run this thing. And that made the system better, that attracted other people, that improved the system. And then, it started to be traded for real money. That also was an event that started to attract more people, and so on and so on. There have been events in the life of Bitcoin that were proportional to what Bitcoin was doing, right? There were no ETFs in the beginning, of course, but there were people started to trade it. So that was a big event at that time for baby Bitcoin. And Bitcoin reacted exactly the same way that is reacting now. Now that is a big, huge entity, there are these ETF, but it's basically the same thing. From a scale point of view, nothing is changing. It's just that now, you need big event to interact with Bitcoin, because Bitcoin itself is big. So, it's the same thing. It's the same thing. And it's interesting, because I know that people want to see skyrocketing price, and, all of us are going to be a billionaire within few years, etc. But I'd rather have a system like this that is consistent, that grows steadily, that shows that is resistance to perturbations, than something that skyrockets and then crashes, right? So we want Bitcoin to grow for decades, for centuries. We want to be stable. It's the first system in the world that is associated with assets, right? The first assets in the world that is so predictable, in an almost scary way because we are not used to this, right? Like we can predict the price of an asset 5 years ahead of time, like I did when I posted my Reddit, right? 5 years ago, I say, hey, this is the trajectory. And I was completely right. Tell me somebody else that is able to predict the price of something 5 years ahead. You know, it's crazy.
And what was the
So
R
sorry, go
squared
ahead,
5 years
ask me.
ago? Do you remember the R squared 5 years ago? As in the regression. Was it 0.92
Sorry.
back then?
Something close to that. Yes, yes. Now this value of a n, right, the slope, um, when you calculate it over this period, let's start in from 2014, can change a little bit, and mostly because imagine I did the calculation when I am just after this big peak in 2014, right? Of course, the calculation will change because I don't have all these other points to balance it, right? So the tilt of a slope will be a little bit higher, right? So it depends where you do your calculation. But I did work with Burger together, and we did some tests, like, for example, we added more and more point, and then we calculated the slope, and then we made a graph of how the slope changes in time, and it simply oscillates over a value. That means it's mostly due to effects like these, where you calculate the slope instead of the system changing the slope. It's, because it's still an approximation, right? Because there are these huge, big changes. There is a lot of data points above a line. There are a lot of data points below the line. And so, you can do stability tests, to see if you're fitting it's stable and consistent. And we did all these kind of things, and it looks like it's very consistent, very, very consistent. It doesn't, so if you project, even if I kept this same alpha, same exponent, and I projected, you will barely see a difference in the straight lines. We are touching each other. And Berger has some graphs to show exactly that it doesn't really change much.
So for the layperson here, the alpha, is that the slope? Because you say you mentioned a lot that Bitcoin is 5.8.
If you look at the equations, right? I show the equations here, right? So it's a very simple equation, and now it looks like a strange because it's all in some notation. But basically, the price of Bitcoin is some constant. It's a very, very small constant. The reason why it's small is because when time was zero, you want to get a price that was basically zero, right? So it's a way of converting price, right? Because we have dollars on the left side and we have times, right? Days or seconds on the left side. This time should have units. The units of this age should be, dollars over days, right? So when you calculate, you get dollars or whatever. So actually dollars, yeah, the dollars over time square, something like that. Yeah, so it's a very simple formula, right? It's basically we are saying that the price goes with the time, and this means basically time from the genesis block. This T1 is the genesis block. So we are taking the difference of the time of today relative to the genesis block, and then you take the power, right? So you raise it to a value, and that value is 5.9. So basically, maybe 6 is the real value, and these are just approximations. And so that is the power. So basically, price goes up with the power of 6. So if you double the time, the power of 2 to the 6 is 64, if I remember well. 3 to the 6, I think, is 720, something like that. You can check it. But basically, a small change in time gives you a big change in price, right? Because we're talking about a huge, big value for n, 6. So you're taking the power of 6, makes the number big, right? So when people say, oh, it's slowing down, was slowing down, yes, but relatively to what? Because it's still growing up very fast because it's the power of 6, right?
So just to quickly consolidate that point. So
yeah.
So if you double the time, the price of Bitcoin goes up by a power of 5.97 or power of 6, as you say.
Yeah. So to simplify, we can say the power of 6, right?
Okay. So if price
it's really
is
5.2 of a yeah. Go ahead.
So if let's say Bitcoin is 40.
Yeah, calculated.
And
yeah. So first of all, take the power. Take 2. Let's start from there. Take 2.
2. Oh, okay. Yes.
Okay. Yeah. Start with 2, just 2, and then take the power of 6 or 5.8. Whatever you like, but 6 will be better, because we can understand it better.
This to scientific. So 2 to the power of, oh no, it's just that one, to the power of 6.
Yes.
So Bitcoin is $2.
It should be 64, right? Yeah, 64. So basically, let's say it took 100 days to go. I don't know. We can check it out, but let's say it went from $1 to $10 in 100 days, right? So that that was a change of 10, right? So because we went from $1 to $10, let's say, and it took 100 days. Now you multiply that number of days, so now you look at 200, it should have gone up by a factor of 64. So 604.
Okay, so let's say Bitcoin's been around what? So let's say price discovery is 2010. It's now 2024. So 14 years. So if you and let's say price is 45k right now. So are you saying with that basic thing is that in another 14 years it will be 45 times 10 to the power of 6?
Right, if you double the time, 15, right? So if you go up another 15, it should go up by a factor of 64.
But
yes.
Wait, what am I missing here? That says that it's 8. Oh,
No. You're taking the power of 4,500. You need to take the power of 2, right? Again, because you're saying is the time that counts, right? Not the value. So if you multiply, not 15, right? So it's relative, it's a change, right? So if you compare 2 times, right? So you're saying if I if I double the time, right, then the price will not double, right? So it's not linear. So if it was linear, the price went from 0 to 45 in 15 years. In another 15 years, if it was linear, it will just go up by another, $45,000. It will simply double, right? So it will be 90, but not. What we are saying that because you double the time, the price is multiplied by 64, so you will go up by 64 times.
What? So
in 15 years.
In another 15 years, it's 45
times 64.
64.
Times 64, yes.
I see. Okay. Yeah. Cool. That's good.
So that is what it means. Now, if you want to calculate any day, right? So you can go back and actually show you how to do that, if you like. Yeah. So if you say, hey, take any day. So I don't know what is. So for example, let's do today, right? So let's say 15 years, exactly 15 years from when it was not today, but January 3rd, 2024, right? So you multiply 15 by 365. This is the number of days from the Genesis block. Now you take the power of that to 5.82. So take the power. Now let's be precise. Let's take 5.82. Okay. And now you multiply this huge big number by 10 to the minus 17.
Oh, sorry. By 10 to the what, sorry?
Minus 17, because it's that A there, that is close to 10 to the minus 17.
Ah, okay, minus 17. Wait a minute, have I done that correctly? Oh no, I've just, sorry, plus 17, one second. So times 10 to the, I guess, brackets minus 17, sorry.
No, minus 17, not 17. You need to put it like a minus. So you're basically dividing by this huge big number.
Cool. Others can do this on the recording. I'm just going to delete.
but you were there, right? If you look at a number, so basically you're dividing, right? So it looks like this huge big monster number, but I can tell you, go back to that number. Okay. So you see this is five quote 719, etc. Right? I can do it in my head, not really, but I know what I am supposed to get, right? So if you're dividing by minus 17, you're going to get yeah, 10 to the minus 17, not 0 to the minus 17. But anyways, look, listen. Look at this. See how this big number 5, quote 719, 994, and so on, right? If you count the number of all the other decimals is basically like 17. So by dividing by 7 minus 17, sorry, by multiplying by 10 to the minus 17, or dividing by 10 to the 17, you get, so cover with your hand everything else, basically you get in 57,019 something. So basically the price today is around 58,000. This is what the formula says. But it's now far away from 45, right? So basically, this is why, you can be below or above that trend line. So the price today, when you calculate it with the formula, it's a $58,000, right? Close to that. And so it means basically that the 45,000 of today is undervalued. According to the formula, I say, because there is like an average value, and that average value gives kind of like what I call the fair value, what Bitcoin should be if instead of oscillating back and forth, it will continue simply to move along this line. But by the way, it seems that what it's trying to do is these oscillations are becoming smaller and smaller, and so it's kind of trying to go basically following this trend more and more. But basically, when you use this formula, what it gives you is the green line, the big green line that you're drawing there. So right now you can see even from the graph, we are below that line. This is why the calculations say 58,000 and the current value is below that. And again, it's very useful because you can see it determines areas when the price of Bitcoin is undervalued. So it's a discount in a sense, and when it is overvalued. And also by how much, right? Because given that these deviations so this is basically 40%. They don't seem to go much below 40%. So we know where to find the bottoms. And it doesn't catches perfectly the peaks because they seem to be kind of more irregular, right? And also they seem to have some kind of decay, these peaks, right? They became smaller and smaller. But for sure, tell you that by the time you are above that red line, it's danger territory, right? So it's a very overvalued. And if you like to play these waves where you maybe want to sell, maybe half of your Bitcoin and rebalance your portfolio, so you can buy back at the bottom, that chart tells you exactly how to do it. So that is another important usefulness of a chart.
So So with the diminishing returns over time, and as you can see, all the peaks, as you said, tend to sort of tail off slightly. Is it as simple as effectively drawing a line from, let's say, these last two peaks and going right?
No. So it looks like, so I did that, and I will have to make some posts. And at a certain point, maybe I'm going to write like a document so people can follow the document through all the different steps and reasoning, something more consistent, or a Medium article, etc., where I guide people through all the steps and all the reasoning behind the model. Because, by the way, I don't know if you have it here in the slides. We can go back. It's the full model where I have the oscillations, right? So look at this. Yeah, maybe we should look at this. Yeah, so now here I go back to what is called the log linear chart. The log linear chart means, while it's useful to look at the log and log, to see that beautiful straight line, we still like to see things in a linear time, right? So you can go back, and this is how that line now that was straight will look like in this log linear chart. It looks curved, right? Yeah, so these when you go back to the log linear, goes to this, right? And the blue curve here is the real price. And look how amazing, right? How amazingly regular it is, right? And so I added to my model, to the power law model, I added these three changes. And this is what the black curve is. I made three changes. One is I say, okay, so the general trend is the power law. So basically a line that will go through the middle of this rainbow. Then I said, okay, force the system to be 50% or 40%, whatever that deviation is, below the trend during the bear market. And I did that because you can see that the price, it's confined by these green bands. So this is why the black line is also confined there, because I force it, right? In my code, they say, do that, right? Because it seems that is what the price is doing. And I added then some sinusoidal oscillations. It is a little bit of a dirty trick, because it will be nice that I had some kind of theoretical model that say, oh, we are going to have these oscillations. My model doesn't predict that. All what I do is that we observed these first oscillations and a second and a third. So it's pretty regular, and say, hey, given that we had these oscillations in a very periodic fashion, then let's add this sinusoidal pattern, right? And it's synchronized to the first peak. So basically I made sure that the peak of my oscillation is synchronized to the first peak, and the other ones are not, are happening simply at regular pattern, and they look pretty synchronized to me because the process is pretty regular. And then I added one third element that was a decay, and that it turns out actually if you plot the peaks, in fact the change, from the bottom to the top, if you plotted this change in a graph, it looks like an exponential, right? So it's actually goes down, it's actually very weird. Even this thing, it's very regular. Now it's 3 points because we had only 3 halvings. So, when you're trying to make a statistical statement using 3 points, you have to be careful because, you don't have the power, you have the stats there. Like the model uses thousands of points, but this statement where these peaks are going down is only 3 points. So you have to be careful. But given the points that we have right now, it looks also very regular. Even that looks very regular. So it looks like an exponential. So I calculated the rate of decay of this exponential, and I change the peaks here, right, the future ones, because the present ones are what they are, but the future ones are base, right, the one that I project in the future, that is, see, at a certain point, the blue line and the black line continues because it's a projection. It's my prediction for the future. So people can call me to it. And I don't, it's not about ego. If it doesn't do this, fine. Then, the hypothesis is wrong, and they will not continue to do what he has done before. And we will trying to understand why, right? So it's still useful. This is how science works. It's not about, hey, yeah, you're a terrible man because you made this prediction and it doesn't work. No, I'm doing science. So I'm trying to use the information I have to make predictions. And if it don't happen, then we can come back and try to learn from it, But if he continues to do what he has done so far, it should continue to move along this black line and peak where I say it peaks. Again, that peak, you can see, right, the future bumps are smaller and smaller because basically I included the decay. So it's not as simple as drawing a line. I use a mathematical function to calculate the decay of these bumps.
Okay, so I guess I worked it out myself, but because I'm not very good at the calculator. But am I correct in assuming that there are 9 marks in between 10 to the power 5 and 10 to the power 6? So this would be 10 to the power of 5.1, 5.2,
yeah, so 10 to the
5.
5. These are normal numbers. It's just, again, they bunch up because we are in a log scale, right? So this will be, the next mark will be 20,000, 30,000, 45,000, right? All the way. Sorry, I made a mistake. 200,000, 300,000, 400,000, etc. So every mark is 100,000, right?
So
As you go up.
if we got a big fat Mars bar and just like try to have a rough, finger in the air type thing, would you say that this is 10 to the power 5.125-ish?
2.5, because this is 200,000, right? The next mark is 200,000. So you are a little bit above 200. So maybe 210, let's say.
Wait, sorry. So this mark here, is that not 10 to the power of 5.1?
So it's a 2 times 10 to the 5. That is 200,000. So every mark is a 2, 3, 4, 5, right? So 200,000, 300,000,
Okay.
and so on.
So sorry that I'm being an idiot here. So let's say I wanted to work out that first mark. What do I put into the calculator?
2 times 10 to the 5.
Okay, so what? 2 times 10. How do I? What do I press on this calculator? Sorry, because before what I've been doing is I thought that was.
So you have a 2 times, right? Whatever time it is in this calculator. Yeah.
Wait, so 2.
No. 2 times.
So 2 times.
Then you see 10 to the x there below, just below.
10. Yeah.
10 to the x, and your x is 5.
And then what? I just press 5.
For some reason, he's already putting. Should I do it?
Yeah. But please go for it. Because I was just curious what these 3 peaks would be, because we're looking at
Yeah. So it's just I can click. Am I able to click? No.
Oh,
no.
Shall I?
It's
would you like
your
to share
computer,
screen,
not my computer.
or?
Yeah, or I can use my MATLAB or whatever, or you can use Excel or whatever. Do you have Excel? I think Excel will be easier.
Okay, so
if you can pull Excel.
Open up Excel.
And then we use Excel because most people can use Excel. Right.
Cool.
So take any. So it's at equal, right? Yep. So put equal 2
equals 2. Yeah.
Sorry. 2 times.
So times
10. Then the little power, right? The symbol for power, that is the caret, whatever it is.
Okay, I'm very special.
The caret sign.
Is it that one?
The caret sign is no, it's it looks like a little triangle. Yeah. 5. Yeah, that is basically 200,000, right?
Okay. Fair enough. And so so going back to, I'll just move that to another screen. So this, get rid of my calculator. So how would let's say it's a little bit above that mark. So
so you're above, so you will say maybe 2.1, right? So you go back and to the Excel for 5.
So let's say...
Because we are just above. And in fact, I do remember I calculated, and it's 2.1.
2.1.
In fact,
so
2.1, so 210.
210,
right?
roughly. Okay. So then if we... Oh, dear Lord. Sorry. So this one will be 2, 3, 4, 5.1?
Yeah, let me check. 1, 2, 3. Yeah, just above 5. So 5 times.
So 5.1, let's say. Times 10 to the power of 5.
Yeah, we're still in the power of 5. Yeah.
So it's 510.
510.
Okay, cool. So next cycle 500-ish roughly, and then
you see how different it is from stock to flow, because stock to flow his prediction, he's cheating a little bit. I'm sorry, because last cycle he was saying that we were going 100,000. His model, I don't know if people realize, his model straight predicts that every time we have one of these cycles, we go up by a factor of 10. So last cycle we should have been 100,000. This cycle now he's changing the numbers, and these numbers are not changed because I'm fixing my model a little bit. No, because actually he's doing some manipulation there where now his prediction is 500,000. No, it's not 500,000 if you stick with what you were saying last cycle, that it was 100,000. So this cycle should be 1 million, right? And then next cycle, it will be 10 million, and then the next cycle, 100 millions. I don't think so. It's crazy. It's not what is happening here. And and not because I want to put down the competition, so go back because I want to really, we are really different philosophies here. So if you go back to stock to flow for a moment, if you don't mind. The previous slide, it was whatever slide you had up before. Or if you want, let's continue to do what you were saying, and then we can go back and compare it with stock to flow. Yeah, so notice how this is something, I had a debating with him for a little while on some days ago on Twitter, and then we even proposed to have like a public debate, and he accepted it, but disappeared. But anyway, so notice how these, for example, in the cycle during 2014, right? The price was above his model, right? Quite a bit. And then the next cycle, it started the distance between the model and the data points. It became smaller, right? And now it's even smaller, right? So it's basically it should, according to his model, the price should have reached that plateau, right? And then kind of stay there. In fact, actually, if you take the model seriously, it should be flat, and it's not, And then, but instead, what happened? It never recovered. It never recovered. It never went back. So this is up to 21. So if you add a net, right? So the model, the prediction was that they should have gone to the plateau and stay on the plateau, and instead, it never went there. And in fact, it looks like there is what I call a decoupling between his model and the real price. He's not really doing a good job in tracking what, initially seems okay. And you know why it seems okay? I'm telling you why. Because indirectly, what he did, because he started with this, he had a chart. If you look at this article, he has a chart between price and stock to flow. He calculates this, it's a theoretical calculation of what the stock to flow should be. And then he draws a graph where he has price on the y-axis, log of price, and he has the log of stock to flow because he's looking for a power law. He even states there is a power law. Now, he's not the first one finding power laws in Bitcoin price. I was one of the first one. I had papers, not papers, but posts all the way to 2013. But I don't know if he read my post or whatever, but he says there is a power law here between price and stock to flow. And then he goes from that to time because, we know how stock to flow changes to time. And he has basically this graph, right? But you know what he's doing by doing that? He basically rediscovered my power law in time that I published before him anyway. Because if you have something that changes in time and you find a relationship with the price, well, in the end, you're finding a relationship between time and price anyway. The only difference is that he imposes on the model one additional condition, that is, there is a jump in 10 every time there is one of these halvings. And that is not what happens. The price doesn't do that. This is why there is this sudden jump. You see this sudden jump? It's basically like a little stair. His model is like a little stair. And that is artificial. He imposed that artificially. And that means that, the system now is different from mine because otherwise he will have reproduced perfectly what I reproduce. And so this is why initially the model follows the price because basically it has nothing else than a power law in time. But then because of this artificial imposition of the price going up by a factor of 10, the two things diverge. And you can see, right, by the next cycle, the price should go, according to his previous calculation, should go to actually 1 million. And it's not going to 1 million. It's not. I would like. And that is cheating a little bit. He readjusted the model because, like I say, if the last time was supposed to reach 100, now is supposed to grow 10 times, so that will be 1 million. So he kind of readjusts the model, and people criticize him for that, and by a lot. Now, slight variation that is due to stats, that is acceptable, but he changed it by a factor of 2. But, even there, it's still predicting a price of 400,000, 500,000, even with this adjustment that he made. And that is completely unrealistic. I don't think he will reach that price. And if that is true, then, next cycle should go to 5 million, if he doesn't do some other adjustments, in the meanwhile. It's I don't know why he's insisting on this. And there is, I'm a little sad because, he's hyping people, hoping, and people even lost money because even when it was clear that we were reaching a peak, he was still telling people that we were going higher, because we were going to 100,000, etc. And some people, you never lose money by investing in Bitcoin. You were going to recover it but many people get disappointed and get out. Maybe, they maybe sell their Bitcoin because they get disappointed. They think it's a scam. So it's not good for the community. It's not good it's not good PR for us. I'd rather be conservative and base everything on what we observe, and and stay with we are still going up, right? And very fast and in a crazy way. Why there is a need to hyper all these, there is no need. And so let's stick to the facts. Now, if we don't observe this decay, great. It's only 3 points. That is the only weak part, is the weakest part of the model, this decay of the peaks. Because even if it is true and very regular, and I included in the model, and so I would rather include it as kind of worst case scenario than and being wrong, because it goes maybe to 300, maybe goes to 400, and then maybe that part is broken, the decay of the peaks, but I still think it will go back to the trend eventually. It will still follow the trend like in my model predicts. Because that is the strongest part. That seems like the most robust part of the model. That doesn't matter what happens in the during the bubble. You always go back to the general trend. That, by the way, the stock to flow model doesn't have any explanation for that. There is no explanation because according to his model, we should be flat during that time. That is completely unrealistic. It's not what Bitcoin does. So they are really different models, very different models. And I think, I'm sorry to say this, not because it's my model, but because, as a scientist, I have to judge these things. This model is superior in many different ways, to stock to flow.
So just quickly going back to very early on in this conversation, you mentioned that Bitcoin is an anti-fragile system. So very much like the internet is. It's like what I tend to say is a 100,000 headed hydra. You can't kill it. Just like you said, the people banning it and whatnot doesn't really affect it. So I was trying to think about what is the thing that makes Bitcoin adhere to the power law. Is it because of the hash rate?
So, okay, there are different levels at which you can answer. The first one is, it's surprising that it's so predictable. At the same time, it's not, because it's supposed to be a network, right? So this network, there is an entire theory, there is an entire science that studies networks, because they come up in nature a lot, like even organisms are networks, right? So our body is a network. There are different organs that communicate with each other, cells that interact with each other. So it's a network. And so there are precise behaviors that are studied, right? Many of these networks, of course, when you study them, are like toy models, but we know a lot of properties about these networks. And power laws come up. In fact, their network are used often to understand how power law get created. There is a lot of evidence, that shows that when you have interaction that look like networks, you produce power laws. A lot of the properties of a network look like power laws. So in one way is something that it's amazing. In the other is something that we actually can predict. And I think you're showing the hash rate, right? So one of the things that I did, one of my earliest posts, and this was all the way to basically 2013, was to show that there is a power law relationship between the addresses and the price. And that actually is something that was uh, interesting because there is a theoretical prediction by a scientist called Metcalfe that he did these kind of calculations when he was at that time telephones were the hot thing, so he was actually not cell phones but landlines, right? So he wanted to try to understand if we have a system like this where there are people in connecting with each other, there are nodes, there are edges, right? So there are the connections in the network. Can we assign a value? So when he thought about value was possibly monetary value, but also utility. What is the usefulness of a network? How a network becomes useful as it scales up with more and more users. And his answer was, it's a very simple calculations, kind of back on the envelope calculation, but his answer was that the value of a network is proportional to the square of the users. And remember what we say, right? Anytime you have a quantity that is related to another one with the power, and in this case, the power is 2, right? If I say the square, that is the power. So in that case, Metcalfe law is an example of a power law. And so when I look at the relationship between addresses and price, and I measure, there was a power law that was beautiful, because one thing is the theory says something, and then actually you observing that, right? And I think actually was one of the first. There is a paper by one of my favorite physicists. His name is Sornet. He is actually a financial physicist, a econophysicist. And he published the paper 4 years after, basically saying, hey, we observed this relationship. Well, I did it 4 years before. My stupidity was not to publish in a scientific paper. But the interesting thing was that the slope was not 2. It was, when I measured it, was 1.45. I think when Sornet measured it was 1.7, something like that. But the interesting thing is that he was close enough to 2, kind of confirming the theory, at the same time demonstrating that what Metcalfe calculated was an ideal scenario. So it was under the assumption that everybody in the network is connected with everybody else. So you get that limiting value. So it's the best possible value that you could get, a factor of 2. But in the reality, Bitcoin is not an ideal network. Of course, like any realistic network, it would not everybody is connected with everybody else. And everybody, we mean, in this case, miners, investors, people that go in the street and talk about Bitcoin. Everybody that interacts in this network is a node. It's a user in a sense. And so the addresses are a kind of a proxy, because the beautiful thing about Bitcoin, that we have a blockchain, and so we can download all this information that is open to everybody, and then you can analyze it. It's the first system in the world that is so transparent, that has all this information about its activity on minute by minute level. It's amazing. And so the fact that that value, that power, was a little bit less than 2 meant that we're dealing with a realistic system. It's not ideal, and in one end is a confirmation of Metcalfe. In the other, it also says that we are not exactly like what Metcalfe said. The only thing is, if now you can say, okay, can I use then how the growth of addresses changes in time to make a prediction about the price? Remember what I said before. If you do this in 2 steps, anyway, you go back to the power law in time, right? Because if the wallets are a function of time, and the wallets are also a function of price, well, basically you're establishing a relationship between time and price anyway. But it looks like if you do this 2-step process, it doesn't look exactly is much is less precise than just doing it directly from time. So that means basically that your idea that there is this straight relationship between addresses and price is not completely correct. There is a lot of noise there. And so, and in fact, recently, maybe because, there is a level 2 layer in Bitcoin, there are exchanges, etc. There is not a one-to-one correspondence between addresses and price like there was before. Uh, so it's still better simply to look at the time, how the time changes, how it relates with Bitcoin, and make a model out of that. And then explain why there are differences, with the addresses or the transaction time. Now, hash rate, I didn't spend a lot of time with hash rate. So if you go back to the hash rate picture, I need to do that. So yeah. But you see, it's a very irregular function. It kind of looks like there is something that is called a Gompertz. That it's also addresses follow that function. The transaction follow that function. It's a function that explains the spread of viruses and the growth of some organism, etc. It's called the Gompertz function. It's not the typical adoption curve, right? So everybody's familiar with the adoption curve. The adoption curve looks more like an S, where if kind of like that. So that was one hypothesis that you could imagine that maybe things like the hash rate or the addresses will follow an S curve, but it doesn't. It's another what is called logistic function. That means eventually it's going to taper off, but it's a little bit more complex than a simple S curve. But yeah. Yeah, so market cap, what the market cap is, is basically price times the supply. But is to me is much better to model price directly, because people is another question that people ask all the time. Why didn't model market per cap? Well, I will model market cap if my model will look better if I express it in terms of market cap, and it doesn't. And plus, market cap in a sense is if I do price versus something else, market cap is there included indirectly, right? Because it's going to affect the price anyway. And so if I describe a price versus time, then you can replot it by taking the price and multiply by supply, because we know how the supply changes, right? So, and as an investors, we are focused on the price anyway, right? Because if I gave you market cap, you will have to go back to price anyway if you wanted to know what the price was. So it's much better to plot it as price, right?
And
Yeah.
And just quickly, whilst we're on this chart, one thing I've mapped out all the halvings and all the cycles and whatnot. One thing I found, which I found interesting, is that all the peaks happen plus or minus 30 days within the 1st of December, and all the lows, so it tends to crash for a year, happens plus or minus 45 days from the 1st of December. So this was the one that really deviated, but every other cycle high and cycle low has always been a year, basically, roughly.
Yeah.
Is it now? Do you what?
I didn't spend a lot of time in modeling these peaks that I should, right? Because if there are irregularities in the peaks, it will be interesting to study. First of all, they look very exponential, in particular this one in 2017. I imagine you are in a linear chart. Do you have a linear price on the log? Okay. So if whenever we are dealing with what a log will look like, like what an exponential will look like in a log linear chart. So log on the y-axis and linear in the x-axis, it will be a straight line. So if it was a really linear, it should look like a straight line. So these are ramping up towards the peak. If it was exponential, it should look like a straight line. And instead, it looks like curved up. That means it was like even faster than exponential. It was really, really fast. It was kind of a little linear in the first cycle, right? It looks like, in fact, you have like a line there. It kind of come close to the line. So it was exponential. The second peak, I remember that amazing bubble. I was there. Like I had an algorithm that was trading Bitcoin, not Bitcoin, it was trading alts, and it did 6 times in one single month, 6 pair in one single month. actually relatively to Bitcoin, right? So Bitcoin was going up as crazy, and my algo did 6 times. I thought I was going to be like one of the richest men in the world. It was like stupid, right? Because of course it was all due to the craziness of the market. But it was really crazy, right? It was going up so fast. And it looks like from this graph that it was actually faster than an exponential, because the exponential will have looked like a straight line, and instead it was going even faster than that. And the next one, you see actually the next one, it looks like exponential, right? So it looks like it's going up along this straight line that you drew there. So actually nice, it's a nice graph. And so it was pretty fast, but it was not as fast as the previous one. Uh, yeah, so there is kind of somehow exponential behavior there. The bubble downs are also kind of look almost like straight lines in this log graph. It again means it's going down exponentially, maybe with a smaller slope, right? It looks like a smaller slope when we're going up. So these are all things that we can learn about the bubble. So I didn't spend a lot of time studying the bubble beside this decay. But I should, that is my next step. So there are maybe some regularities about these bubbles. And you're right. I made a little movie. I don't know if you guys saw it, but maybe you can have a link when you present this. I made a little movie. The idea is now, because I want to give credit where credit is due. Somebody else plotted Bitcoin in a circular map, because you can do all this transformation. We do this transformation in physics all the time. Yeah, you can show this little movie. It's really cool. So basically what I did here, like I say, somebody else has done this before, but again, it's something that we do all the time. We plot things in different ways in physics to understand different patterns. So what you can do in this graph, what I did in this graph, yeah, because this graph kind of answer your question. So let's keep it there. So what I did here, I made it in a movies, and there is some music. So when you guys have chance, look it up because it's kind of cool. But in this graph, the radius represents price, right? So as you move away from the center, you have higher and higher prices that are indicated there, right? You can see the 1,000, like here, for example, right? 10, 1,000, 10,000, and so on. So as you move away from the center, you have prices. And then every time the price goes around the circle is 4 years. So it's a way of showing. So basically the angle represents time. So as the angle changes, you have more and more time. And when you do one full cycles, 4 years are passed. So it's a way of showing the regularities in time, right? So the periodicity in times of Bitcoin. And notice how, for example, all the peaks. So in addition, so the person, I think it's called Rational Root is a Twitter account, right? Rational Root is also a Bitcoin analyst. And this idea, these are not new things, but applying it to Bitcoin is a new thing. So he needs to be credited for that. It was a cool idea. I didn't think about it. I did other things to show the regularities, but I didn't think about plotting it in this way. So that is contribution. My contribution here is to add the power law. The power law here is the orange line. So look how beautiful it is. So when you plot it in this way, now the power law looks like a beautiful spiral, very regular, beautiful spiral. And then on top of that, I put the full model, right? The full model with the bubbles is the red curve. So the red curve that is above, you see how the red curve follows the peaks, right? So the red curve follows the peak. That is the bubble, right? Now they don't look anymore like bumps. They look like this spiral has been stretched somehow, right? But it's the same question. It's exactly the same question. Now we are plotting it in a circle instead of a linear, a flat graph. We are putting it in this weird transformation, in this weird map. But it's still interesting because you learn so many things. Like, for example, you see how regular the peaks are, right? You were right. They tend to happen more or less during Christmas or, the end of the year, right? So these where all the peaks are. I highlighted in red basically the bull markets and in green the bear markets. And so they all happen more or less during the same time, every 4 years. And then same thing with the bottoms. They happen all close by each other. So there are a lot of regularities, in the behavior. And yeah, you're right. So if this is 4 years, right, it takes about 1 year to go from the top, because a quarter will be 1 year. One quarter of this circle will be 1 year. So it takes about 1 year to go from the top to the bottom. The bottom happen here on this third quadrant. They're all aligned during there. So it takes about 1 year from the top to the bottom. And usually is also very regular. It takes 1 year to go from the time we start to cross this line, because when these two models, right, the full model and the power law model, the simple power model, cross each other, this is when we get this bull. And again, it's about kind of like 1 year to, so 1 year to go up, 1 year to go down, and everything else is basically the bear market, these 2 years. But it's not a bear market at all because we're still going up. So I was making this joke on my Twitter that basically Bitcoin goes up, 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 up during what we call the bear market. It's bear market in comparison with the bull market, right, when the price goes crazy, but it still goes up in a very regular fashion. And, so maybe we don't ever have bear market. We simply go up, and then every 3 years, Bitcoin goes to Cancun, it takes a vacation, and it goes crazy, and it has fun, and it gets drunk, and it reaches a top, and then, it gets sober again. It has a hangover, and it goes back to the trend, So that is one interpretation of what is happening with Bitcoin, that we are really never in a bear market in a sense. Because even during the bear market, during the bear market is when the price is most regular, it follows that trend in a very, very tight way.
Yeah. So what longevity is a question which I've been thinking about a lot. And so you're saying that with anti-fragile systems, and the more data, it's more likely to stay power law. So obviously I'm just a trader. And so when I'm looking at this, because I'm only using this one just because I can manipulate it. Now, obviously,
yeah, finally they are giving me credit, because before,
yeah, that's new. So let's just say it does stay on the power law for a while, and this goes up to 2040. But if we were to draw a line,
can you make it bigger if you don't mind?
Yeah, sure. Sorry,
so we can.
And then I'll move this way, and then I need to stretch this axis. It's not the best chart in the world. I have to. Whoop, there we go. But what I was trying to say is that, okay, let's say it goes on for, I don't know, another 50 odd years. I mean, it's going to put the price at something ridiculous, like $100 million Bitcoin.
No. In 10 years, it's going to be. It should be 1 million.
But I mean, like in say 50 to 100 years, if it continues with this. The issue that I'm having is that there isn't enough GDP or currency on the planet for
of course. So this is the way of thinking, right? So what I'm saying all the time is, look, if he did this for 15 years, probably is going to do it for 10. So how spoiled are we with Bitcoin, right? It's going with the power of 6 up. Oh, it's too slow, I would like to be exponential, like S2F, because S2F basically is exponential. If you have something that actually multiplies by 10 every 4 years, it becomes exponential, right? So it's even crazier. If people think this is crazy, okay, go back to S2F to see how crazy that is. But, so what I'm saying is, it's going to go up, and probably is going to do in 10 years what has been doing in 15, is pretty good hypothesis that it will continue to behave in a regular fashion for the next 10 years. And, by the time Bitcoin is $1 million, I don't know how many Bitcoins you have, but I'm going to be happy if one Bitcoin is $1 million. Right? And we are spoiled because we are making prediction 10 years ahead. Like, like which assets you ever done that, right? Not even the SP 500 or anything like that. Yeah, you can make some rough guesses, but here we are trying to make very precise predictions. So it's amazing that we can look at 5 years, 10 years ahead of time, like I did in my post. I did a prediction of 5 years ahead, 10 years, amazing, right? When is 1 million? Let's see if he did. We will going to have another call. Maybe we are going to have a more frequent calls, if you don't mind. We can have other kind of reviews, like every few months, maybe every 6 months, we can check what is going on. But in 10 years, when it's 1 million, we all celebrate and then see what happens. Maybe there will be a change of phase where Bitcoin is going to do still a very regular behavior, but the fact that there are limits to the growth of something, like, for example, we do grow like power laws. People grow with power laws. I was showing the other day on my Twitter a model of how teeth grow. They are perfectly power laws. Human bodies grow like power laws. But, evidently we don't grow and became giants, right? There is a limit to how much we can grow, and that is when the system then goes through a phase transition and changes and then even stops. Of course, that is going to happen, right? And the model doesn't have that component. I could try to add it, thinking, there is some kind of limitations or whatever, maybe it's tapering off, or, I can add some other component to take in account of that and will be interesting. But, I try not to add so many things, because anytime you add something is artificial, it's not based on what we have observed so far. So, I don't want to make the model super complicated. It could be interesting, but right now is, this is what the model has done. It's called a heuristic model, basically based on observation, right? So with the model, the price of Bitcoin has done this thing very regular. Maybe it's an approximation to a more complex behavior. And so it's not really a power law 100%. But so far, a power law, it's a very good approximation of this model, and has been predictive in the past. It could be predictive in the future. This is all what we should do, So let's see if it works for the next. For example, right now, the big challenge is, let's see what happens during this cycle, So this will be very interesting. So yeah, you're writing that, right? So to do science, you need to make sure that whatever hypothesis you have can be invalidated, right? If we say in science, it needs to be falsifiable, because you can make a statement that is so ridiculous and is not linked to anything observable that, okay, you made this statement, but really you cannot prove it or unprove it, right? It's not falsifiable. But when you have something like this, that is can be falsified, because, you can look at what happened in the future. If it deviates, now we will have to decide how much it deviates to really be a valid invalidation of a model, but it can be invalidated. And if it is invalidated, we will learn something from it, right? We will say, okay, why, instead of focusing on the model, because models are always wrong. We have this saying that all models are wrong, some are useful, right? So this one is useful because it's making prediction, has been right in the past. It tell us that there is some very nice regularities in the price of Bitcoin. And if it happens to be really badly wrong, then, okay, we will have to go back and say, hey, what happened? What happened in the modeling? What happened in the price of Bitcoin? What we can learn from this. But, given that has such incredible track record, I can leverage this. You say you're a trader. If you see something like this, right? This is not back testing. This is not back testing like where I'm overfitting something. I'm not overfitting anything. There is no overfitting here. It's just, it really looks exactly like what Bitcoin is doing, and roughly, right? And so it's a good predictive model, and one could bet on it. With of course, anytime you bet, you take some risk, but I don't know. It's possible probably to do even a calculation. How likely is that, given what has done right now from probabilistic point of view, how likely it is that it's going to continue to do the same for the next 2 years. That is basically when the peak is going to be reached. and so on, right? So it's something that I want to use it to trade. I want to use to trade because when the model is going to tell me that we are in this red territory, I'm probably going to sell some of my Bitcoin because I want to rebuy back at the bottom, you know? So I want to ride this cycle. So I did a calculation that if you play you use, let's say this model is 100% correct, right? And you are crazy where you really trust it 100%, like you put your life on it, and you sell all your Bitcoin when it reaches the top, and then you buy back when it reaches the bottom, and in fact, you even short going down. So it was kind of like a crazy best case scenario where this model is perfectly followed, and I'm going to track it to the dot. From here to there to this 1 million goal in 2033, we have a 320 pair gain. So there is still 320 times, not percent, but times. So in fact, I made a graph where imagine a company, because I want to actually start to talk to companies to do this business model where you do what Sailor is doing. So basically Sailor is borrowing money to buy Bitcoin because he's thinking, well, I'm paying, I don't know, probably his rate is almost zero, right? His borrowing, level is, his percentage interest is really low. But, the average business, maybe we can get a loan at 7%, 5%, whatever it is, right? Even 10%, it will be a rounding error in comparison with 320 pair, right? So if you borrow 100,000 and you end up with 32 million, right? This is what happens. You get $32 million from $100,000 loan. You can pay the loan many times over, right? It's going to be a rounding error in comparison. The interest that you pay on the loan is a rounding error in comparison with your upside. So where do you find an investment where you have a 300 pair upside versus 10% interest or something like that on the loan? And maybe it doesn't do that. So if a worst case scenario, so I did 3 scenarios. I can send it to you. I did one where you just hold, so we're talking about what, a 20 pair, because we are going from 45,000 now to basically a million in 10 years from now. So 20 pair. And then, there is a little bit more aggressive scenario where you simply sell and then rebalance, right? You rebalance your portfolio. You can also rebalance maybe half of it. You keep half in Bitcoin and half in cash, and then rebuy at the bottom. So you can think about all kinds of different scenarios with different level of risks. The riskiest one, where you go all in and follow the cycles and short down. When it goes down, it's 300 pair. That was my kind of like best case scenario, right? Like my upper limit. So there is a lot of room there. And differently from anything else, like, different alts that maybe can go crazily up, right, momentarily. We're talking about Bitcoin. So Bitcoin right now is a very, very safe investment. So maybe it doesn't do 300 pair, but for sure it's not going to zero, right? So I'm sure that it's a very, very valid strategy to borrow some money for a business and put Bitcoin in their balance sheet because, it's one of the best investments that you can imagine. And I'm not the only one, right? There are now institutions that are claiming that. Like there was some kind of a report sometime from, I don't remember which one, but one of the large institutions say, oh, you know what is the ideal amount of Bitcoin in your portfolio? And they came up with a crazy number, like 80% or something like that, right? Now, when we want to be conservative, say, oh, we should have like maybe 5% or whatever. But actually, when we did the actual calculation was like, you should have like 80% of your portfolio in Bitcoin, So it's
just quickly, yeah. So is there a point which the average Joe should look at to see whether or when or if Bitcoin is invalidated in the power law? Is it just a case of the price action just stops following?
Well, the average Joe, I'm not sure if the average Joe will be able to tell, but I will tell everybody, like follow my Twitter, follow my my account because I will be the first one to say, hey, it's not behaving like before. It's not about ego. There is no ego in this thing. It's science. We're trying to understand Bitcoin. We are all students of Bitcoins. And so it's a valid question. I will spend some time in the next few days to say, when can we tell that the model doesn't work anymore? One of the things is this power, this 5.8, because like I say, we did some tests about how stable it is and how regular it is. And right now it seems to oscillate around an average value that indicates that the model is stable. If we start to see some large deviation of this power, right? And I will do some calculation and say, okay, we need to go far away by this amount to tell that we are not going to follow the power law anymore. But there are ways of determining, okay, the model is invalidated. It's not true anymore.
And just to look at the low of say, let's say it crashes for a year, etc. I'm just trying to work out that low. Is that correct? 48K?
60,000. I think I calculated it's about 60,000.
So in this,
and you can maybe check from the
in the spreadsheet,
graph.
what does the sum look like then? So I thought that was what, four? Let's say it's 4.8.
So you're actually you extended the line and it was there just below. Yeah, so actually it's even higher than what I said. So closer, because the dot, the little mark below 10 to the 5 is going to be 90,000, right? And then the one below that is 80,000. So probably close to 80,000. I don't know if your straight line is really straight. I think when I calculated it was like more like 60,000 at the bottom there, but in that region, right? So we will never go back more than 60,000.
But in the spreadsheet, just because I'm stupid, how do I work out that number again? So to work out, let's say that's
whatever it is, if it is like 2 marks below, so the one below is going to be 9, the one below will be 8. So it's going to be 8 times 10 to the 4, right? Because now we are in the range of that is that is 80,000, right? Yeah, your line is, I think, is a little bit tilted. When I calculated, because I remember I did the calculation, it was close to 60. So, we're talking about $60,000. So it will probably reach a peak of 210, close to that value, and then go down to 60,000, and it's never going down more than that. Never again. This is what the model says. Now, it's possible the model is not correct, and that is not, but if a model is correct, then this is what it will happen.
So obviously anyone that gets into crypto, hopefully they understand the power of Bitcoin and why Bitcoin. So like basically everything Michael Saylor's ever said about Bitcoin is spot on in my opinion. And the interesting journey that it took me is that myself and my community, we stumbled across another crypto which is very similar. I guess the saying on the internet is that Bitcoin was the test net for Casper. And it's as though Satoshi looked at what Bitcoin did over the last 15 years and had his head in his hands and went, this is not what I wanted. He wanted peer-to-peer electronic cash, etc., etc. And so we went down the rabbit hole with Casper, and that's why I sort of asked nicely and prodded for you to do the power law for Casper. And and this is your chart that you, for anyone watching this is what Giovanni came up with. It's 92.9235 regression, which would you say that's actually very accurate then for something which is only 2 years?
Yeah, I like for Ethereum, for example, it's 0.8, and it doesn't look like it doesn't really look like a power law ETH. You can always fit a power law. It's just that you will get a bad R square, like a lower value. It doesn't really look regular to me. And in fact, so far, I tried few, and I will continue. Probably I'm going to actually make a catalog of all different coins and see what we get in terms of N. So the values that we are interested in are these N, because N is almost like a fingerprint. It's a fingerprint for the system. And the R square will tell us how good of an approximation the power law is. Now, I want to make a caveat though, and the caveat, I want to claim there is a caveat. The caveat is with Bitcoin, we went, from Bitcoin being few cents, right? So here 10 to the minus one, all the way to almost basically 100,000, right? When it went to in the peak 70,000, so it's close to 100,000. But we are talking about, 7 order of magnitudes for Bitcoin, and so it's much more dramatic, the idea that it actually follows this power law and is much more valid. While in this case, we are talking about, going from 10 to the minus 3 to 10 to the minus 1, so 2 order of magnitudes. So is up, and, the only way, remember we are saying we are looking at changes of magnitude. So if we just went through 2 order of magnitude, it's interesting. It's indicative of something, but I will not, take this too seriously right now. It needs to go several order of magnitude up before we can actually say that there is a power law there. But so far, look at this graph. It looks really nice, right? It looks really nice. It's an interesting feat. It looks very regular, right? There is a general trend. There are oscillations around this trend, a deviation from the bottom. You see, this is what you see all the time also with Bitcoin. The deviation from the bottom is always smaller. Like for Bitcoin, for example, this red line that touches the bottom is like one standard deviation relatively to the trend. I didn't measure it for Caspa yet, but it looks like it's smaller than the peaks, right? So for Bitcoin is two standard deviation up for the peaks and one standard deviation down for the bottoms, and it looks like it's kind of regular. This type of distribution, by the way, is called log normal. So basically, it's not like a Gaussian around or a bell curve around the middle ground, but it's more like it has a tail, has a long tail towards these peaks. So it's interesting. It's very regular, and it seems predictive, because it looks like it's doing this and it will continue to do this. So we will monitor it and see, right? But it's very interesting. Also, so if you take it seriously and you play this little game and say, hey, maybe it's a baby power law, right? So it's kind of behaving like Bitcoin. And is because Bitcoin, right? We claimed it was a power law even when it was a baby. So here now you have a baby Bitcoin, maybe, and is behaving like a power law, like a Bitcoin did. In fact, Bitcoin was crazier actually in the beginning, mostly because I think there were a lot of manipulations, like Mt. Gox and all kind of stuff like that. And so this is very much more regular behavior. The R square is very good. 92% basically means that this very simple model accounts for 92% of behavior of Caspa. It's pretty amazing, right? And it's nice to have simple models because, they are simple and they're reliable. And so if you go back to the chart, I wanted also to point out something else. Yeah, so the N, right? The N is the slope and is the power. So basically what this says that the price of the Caspa goes up with the power of 4.46. So you take the time, again, all this is the time from the Genesis block. So the CAS, in this case, the CAS Genesis block. So you count how many days are passed from the Genesis block, and then you take the power of 4.46, and that tells you the price. And so it's predictive because we can do this for any future date, and then we can say when. So I calculated, I think it's 1.4 years from now when it will reach $1. 1.4 years from now.
Cal,
it will take another 1.4 years to go up by a factor of 10.
So I'm just trying to work out. So today,
mid 2025.
Where is it? Count the days. So end date, let's just say 1st of December 2025. Sorry, please humour me, I'm sorry about this. So we've got 662 days left until what we think is, let's say end of December is peak cycle. So 662 days from today is so what is that, 825 days when you did this?
Well, it's going to be before that. So if you're interested in when it will reach $1, it's like 1.4 but it's basically 1.5 years, right? So it's going to be like a middle of 2025. That should be kind of close to when the peak of Bitcoin is going to be, because the peak of Bitcoin is going to be close to maybe December 2025. Yeah, so and just to finish my point, if you don't mind, notice so for Bitcoin N is 5 point, close to 5.8, 5.6, whatever, and for Caspa is 4.46, so it's smaller. So actually, it's growing in a smaller fashion than Bitcoin. Now, of course, being early in its development, there are more possibility for upside, right? Because it's always time relatively to the Genesis block. So, in the beginning, because it's not an exponential growth, right? Early on, it grows faster, from in a linear, if you think linearly, it grows faster in the beginning, then it kind of slows down. Again, it doesn't slow down if you focus on order of magnitudes, but it slows down linearly. So there is still, this is why, for Bitcoin to go up a factor of 10 is going to need 10 years. For Caspa is going to take only 1.4 years.
Okay, so is this correct then? December 2025 is 662 days away. So does that mean, in order to try and work out what the price of CAS is, does that mean December, that's 1482 days from Genesis? Is that correct?
I did it somewhere. I will have to pull out the calculation. I can send you a table if you like. So, we can look it up. But right now, I had in my mind that these because I calculated, just like I knew that you were going to ask me these. It is basically 1.5 years from now, whatever that is.
But I'm just trying to understand the calculation. So if, let's say, that date is 1482 days away, how do you work out the price?
I don't think it's 1,000 from what? From the Genesis block? Because 1.5 years is closer to 500, right? Something like that.
I was just assuming this is
550.
If that point there, is that 820 days from Genesis?
Sorry?
So this point down here, is that 820 days from Genesis?
Yes.
So, and December the 25th, so December 2025 is 662 days away from now.
No, like I say, it's 1.4 years from now, from today. So 1 year from now, it will be February, right, 2025. You add, so 4.4 is basically, close to 5 months or 6 months or whatever it is. And so we're talking about, June or July of 25, something like that.
I know, yeah. Sorry, without labouring, but I was just trying to find out.
June or July of 25.
Okay, but I was just curious what the price would be in 1st of December 2025. And I was trying to work out how.
I don't know. I will have to calculate.
Okay, never mind. Fair enough. Yeah, we're gonna have to start rounding up because it's been.
We cannot calculate it right now on the spot because we don't have the other value that is a, that little constant that goes in front. I don't remember what it is. I think 10 to the minus 14 or 13.
Fair enough.
But I can send you the formula. I can send you a spreadsheet so we can calculate it. Every month or whatever. So we can make projections. That if it continues to behave like is behaving right now, that is amazing. we can even predict the bottoms. I mean, at least tell, if we are close to the bottom. We can say when we have these oscillations, we are close to the top. It's very predictable. It is kind of
Yeah.
crazy if it is true.
Okay. Well, that, that's amazing, Giovanni. Thank you. I mean, it's been what, almost 2 hours now, so um, I think we should probably end there. And I just want to share with everyone.
You have a time for maybe questions from
Yeah, in
people?
fact,
Maybe
yeah.
like we can spend
Do
5 minutes.
you have, say, 15 minutes for quick fire?
Yeah.
Oh, lovely. Um,
This is what I do all day long. This is now my
Amazing.
full-time job. This is why, sorry if I pitch myself, please, if you can support me on Patreon, because basically I'm quitting everything else, like I quitted my other activities.
amazing.
I have also another startup, but I'm focusing 100% on this because, of a halving coming in, and I want to help investors. I want to help Bitcoiners, so my full focus right now is on this project. So I'm, I will appreciate any kind of support and appreciation from the community. So if you want to, I basically created a Discord channel where we are going to have this kind of discussions on a regular basis. And, people can ask me questions, so they can interact with me. I'm going to do daily updates. I'm going to post charts. If people want to learn how to do the calculations, I can teach them. We can have one-to-one sessions,
And
whatever.
that's all in this
But
one here,
basically,
the insiders.
yes, you're getting a lot of and also even I mean, even just the $5. This is pounds, but okay, so it's basically $5 subscription. You get a lot of benefits,
Yeah, I'll
and
definitely
then
join.
if you want a more like one-to-one interaction with me, where I can show you all my calculations or my thinking, etc., then there is this more, higher level of subscription. But we are all very reasonable,
Oh no, yeah, it's
and
very
so
good.
I would really appreciate if you can support me and join my Discord channel through. It goes through Patreon,
Yeah,
basically. So you're yeah, and even if you just want to support me simply because you think that my work is cool, I appreciate that. But there are a lot of other
yeah.
benefits. Sorry if I pitch myself for
Not
a
at all.
couple
No,
of minutes here,
I
but
want you to get your message out there to the world. So I will spread your Patreon link, which is what you sent me here. I'll definitely be
yeah,
joining, and I'm pretty sure a lot of us will join you as well. Also, we will go to Q&A, but there's some
yeah. So
people.
I would like to take some questions from the people if
Yeah,
anybody
I was
has any
just quickly
question.
sharing your link. So basically, Giovanni is the Paolo or Giovan 3508. Catchy. There's that one there.
Yeah, I should change that, but there are so many links now to that account. I'm learning about all this social stuff, so
And
uh,
yeah, and
but you should be able to find me online
definitely.
easily.
And his YouTube is Quantonomy. So as you can see, I've watched
Hmm.
quite a lot of your videos
Yeah, and by
already.
the way, there is this little video that my son made. This animation is like a video maker, and yeah, that video is about here. This a Bitcoin power law and the launch of Big Poseidon. So we are working also beside of a Discord channel. That is what we are
Got
having
it.
right now as a tool to help the investors. We are also developing an app, and so there is like a little explanation of the app in that little video here on the side, on the channel. So if you want to click on it, but basically the idea of the app is that instead of you looking at the chart every day, etc., we will automate everything for you. So where the app will know where we are relatively to the cycle, and you can kind of personalize, like I told you there are different degrees of risk that you can take. Do you want to short? Do you want to go all in? Do you want to do 40-50? So it basically is doing DCA using the knowledge of the cycles, and it's going to be all automated. So you don't have to use your emotions. Should I do it now? Should I do it tomorrow? It's going to be all mathematical. And you can adjust your level of risk, how much risk you want to take. So we are still working on that. It's not ready, but we are preparing ourselves to launch
So what
that
questions
app.
do you all have, folks? We've got probably about say 15 minutes. Does anyone want to unmute yourselves and ask Giovanni?
Yeah, just a very quick, simple
Go for it, Will.
one. Does can this be applied to pretty much all altcoins, assuming that they have enough price history?
So yeah, first of all, there is the limitation of price history, but then when you apply, right, for example, Ethereum is one of the best candidates because, among the older ones is, is, I mean, among the different crypto is one of the oldest ones. It doesn't work. So it doesn't, I mean, you can do the calculation and you can get a value, but it doesn't look like a power law, like it doesn't fit. I don't have a graph here, but I would, if you come to my channel, etc., I have that in, for example, in my Twitter account, it doesn't fit very well. It doesn't, you can see that it doesn't follow that power law. And then that R square, that is a mathematical way to say how good the fit is, it's not good. It's like 80%. That actually is not difficult to get an R square of 0.8, 0.81, and this is what happens with Ethereum. And like I said, I'm going to do it with all the coins just to see how different they are and how far away they are from a power law fit. But so far, this is why I was surprised about Kaspa. I have to say Kaspa is the only one that I found that I will say it looks like a power law. Nothing else. And in fact, not just other cryptos, but I tried with gold, I tried with silver, I tried with the SP500. There are no other power laws that are so beautiful like with Bitcoin. Over 6 orders of magnitudes. There is nothing. So no, it's not something like, oh, let's do it for all of them, because this is why, for example, like TradingView, right, which is one of the charts that tools that people use all the time, it doesn't even allow you to take the log of time because it's not useful. Most of the time it's not useful to take the log of the time. But with the Bitcoin, it is.
Amazing. Thank you, Will. Any other questions?
Well, I guess just adding to that, is it likely that Bitcoin and CAS seem to work well because of their fair launch and their tokenomics? Or to put it another way, things like Ethereum and the expansion of supply and all the goings on in other cryptos, is that the sort of noise which messes up the power law?
Right. So I say all the time, right? It's a joke because I'm not Kepler, but basically it's like I am Kepler, right? I found this pattern that actually was a power law between the distance of the planets and the time it takes for the planets to go around the sun. That is an amazing, beautiful power law. It's actually, because we are talking about planets, there is almost no deviation to the human eye. It looks amazing, like God made it or something, right? And then Newton came about, and Newton took that relationship that, Kepler had no idea what was the mechanism, and he was able to show that it's due to gravity. This is why the planets behave in that way, because there is this theory of gravity, gravity behaves in this way, and this is what drives that very interesting behavior of the planets. I wish there was a Newton to my Kepler here, right? Or maybe I'm trying to be Newton too, but it's so complicated because, with the planets, it was a crazy effort that Newton did. I don't know how he managed, because it was incredible, in particular, given the math knowledge of the time. With something like Bitcoin, is even more complicated because we're talking about a complex network, all kinds of different things coming together, different forces, etc. So I don't know if we can model it with one simple factor like S2F, right? Oh, S2F is the main driver of this. It's going to be complicated, but evidently, right, there are things that we can kind of say about the system just looking at the behavior, right? So if the behavior was so regular and there is some similarity between CASP and Bitcoin, it says something. It's interesting. Now, why that is so, we will have to see. But it's a statement, there is some relationship. And in fact, maybe one can classify different coins according to how well a power law fitting works for them. and what is their N. So it's a way of actually judging the value of a coin, because there is a lot of nice behavior. Rather, some people will like an exponential behavior, right? Like it goes like crazy up and up faster and faster. But I like this better because this means it's sustainable. It's a resistant system. It's anti-fragile. It's continue to grow in a very fast way, because remember, we are taking the power of almost 5 years with time, but it will continue to do that, when it's $1, when it's $10. I know some people think it's impossible for Casper to go to $10, but we can actually predict when that is going to happen. I didn't do that calculation yet, but at least $1 it should for sure reach $1, and we can tell when. Now, is it going to continue to behave in this way? Look how regular it is. It's amazing, right? Even in this log linear chart, you can see it's a very beautiful fitting, and it's not just about the fitting. This is what I'm trying to communicate to everybody. It's the philosophy behind the power law. So it's not just, it's just another fitting. It works, it's useful. No, it means something about the system. Tell us something about the nature of a system we are dealing with. It's not another power law. I mean, it's not another model. It's not another equation. It's something deeper.
Yeah. That's amazing. Any other?
I have a.
Sorry, yeah, go for it.
I have this. I don't know. I don't know if I can show it to you, but maybe I can share the screen for a moment.
I'll make you co-host.
Just a joke, but it's a cool joke.
You can share your screen.
It's this one. So I want to go to the next Bitcoin conference with this shirt. Actually, I didn't make the shirt. It's physicists are so enamored with these power laws that we have this internal joke that we like them too much a little bit, So somebody made this silly shirt saying, I went to a physics conference and all what I got was a lousy power law. And I modified it and say, Bitcoin conference. Because I want to go actually I asked the next Bitcoin conference if they let me speak, as one of the speakers, and want to tell about this story. But, I'm going there with this t-shirt. And that is my model below, this one of the nice colorized versions of the model. But it's a joke, and at the same time it tells us something powerful, about what is going on with Bitcoin, if the hypothesis is true, and if it applies to CAS. Now, let's try with 100 coins. The problem with most coins is that we don't have enough history, but we don't have enough history with CAS, and it's already showing power law behavior. So let's see if there is any other coin that shows power law behavior. So far, I didn't find any. So I will do a more systematic study and then see.
Yeah. And one thing which
and by the way, this is the CAS graph.
Lovely.
Yeah. Great.
Do you mind if I just share the screen?
Give maybe space some other questions if anybody else has a question.
Yeah, go for it. Any other questions?
Sorry, me again. If no one else pipes up, with that chart on the screen, just to clarify, if there's a prediction that middle of next year, CAS could be around $1. Are we saying that the prediction is that would be the fair value, i.e. the pink line?
Yeah,
but it could be at that point in time, it could be up to 2 standard deviations higher than that, or 1 standard deviation.
Correct.
Yeah.
Right.
Cool.
And we can calculate what that is. We can do. I will create a graph with the projection, up to $1, let's say, because beyond that is kind of silly. So let's stick to $1. Let's see if it follows that path, and we can put these bands, that are 1 standard deviations and 2 standard deviation. Then it should give us a range, where the oscillations are, and maybe there is some regularity to these oscillations, which we should study them too. But it's very interesting. I have to be honest. On my Twitter channel, I have to be careful because there are a lot of maximalists there. That when there have been people say, I'm not going to follow anymore if you're mentioning another coin. I don't understand because I think it's crazy to be fundamentalist like that. It's true that Bitcoin is better than anything else so far in terms of how large the system is, how many people are getting involved. That is all true things. But, why, there is an ecosystem of different coins and they bring some value, why not? And if you are a trader, you're not, enamored to a coin. You want to understand it. You want to invest in it. You want to maybe to come out. And if you're long-term Bitcoin, you can, sell and buy other coins and get more Bitcoins. Why not? So I don't understand this fundamentalism. But I have to say, I actually studied a little bit CAS, and I did like it. I know some of the lore behind, that supposedly maybe the guy that made CAS is Satoshi. I don't know. I don't think so. But, there is some interesting analogy and parallels. And I did get some CAS. I'm interested in the coin.
Nice.
So, yeah,
Any other questions,
it's
folks?
pretty cool.
Can I ask
Go
a
for it,
question?
Christos.
Sure.
So if I'm understanding this correctly, I understand the power law, but the highs and lows, for example, when you were able to sell, cash in on a profit, and then use some of that money to go back when it's a low, you're getting those highs and lows through the power law as well, or that's a different formula that you are using?
So you're talking about the oscillations, right? So these oscillations, yeah, correct?
Yes, yes, yes.
Yeah. So this is an addition to the model, right? It's the model doesn't predict these bubbles, so it will be nice if I add some mechanism for the bubble. All what we're doing here is say, well, look, we had 3 bubbles now. It's not really enough to make a statistical statement, but it's pretty likely because it's not just the statistical statement, but it's also some causations, right? We are saying, and these actually have to be honest. Plan B was one of the first people. It was obvious that something will happen after the halvings, but he was the first one to say these bubbles are caused by the halving. And I want to admit that was one of his best contributions. And so it's true, really looks that there is some kind of correspondence between when the halvings are happening and the bubbles are happening, and it happened 3 times. So maybe it's going to happen 4th and the 5th and the 6th time, right? It's the weakest part of the model because, like I said, instead of being based on thousands of points, it's based on 3 events. So it's all based on if these bubbles have happened in the before and they are so regular because they seem to happen more or less at the same time, then I can predict when the next is going to be, how big it's going to be, because this decay is also seems to be very regular too. So given these 2 factors, the periodicity of the bubbles and the predictable decay, that is my best guess of what is going to happen. Even if it was not that component, we can still see that the deviations from the trend are also predictive. Because even if it was not this regular behavior of the peaks, by the time you're in this red territory, it's probably a good idea to get out. So you don't need the bubble, you don't need this extra component to make nice predictions about what is happening next, because the model tells you it's good time to buy when you are in the green area, it's bad time to buy in the red area. In fact, it's probably a good idea to rebalance your portfolio then, where you want to, if you are all in, you sell all your Bitcoin and you wait until you can buy them back here. Or if you are so attached to your Bitcoin that you think is a risk to sell them, because, it can still maybe break the model and go up, you want to maybe to sell half of them, and do what is called rebalancing, right? So you're selling your Bitcoin because they are overvalued, and you rebalance by being in cash, and then you do the opposite when you're in the green area. You get rid of some of the cash and you buy Bitcoin. And if you do this, you don't get 320, you get maybe 100 something, you still get a crazy upside. I think it's 120 or something like that. I don't remember. Makes sense because, if you short, you basically double that. So if you time correctly these oscillations, even if they are not perfectly timed, by the time you go in the red area and you sell and you wait for the green, you're multiplying your Bitcoin by a lot. Does that answer your question, Christos?
Yes, thank you very much. I mean, I like the idea of you said rebalancing. I'm someone who's very attached to the Bitcoin. I'm always afraid to sell it, but I think you've explained the way it works that someone like me who had that attachment can let go a little bit.
Okay, so for example, in our app, right, the app we are building it where we are going to kind of tailor to the style of investing of different investors. So if one wants to be completely attached to the Bitcoin, then the advice will be continue to do your DCA, right? Because imagine you're still buying a little bit of Bitcoin. In fact, the app can help you with that. You can say, I want to buy $100 worth of Bitcoin every week or every month or whatever, right? Particularly if you are a young person, you want to do that, right? So the app will help you because, okay, you don't get rid of your Bitcoin, but maybe you can buy more during the green area and buy less during the red area, right? So save your money to do the DCA to when is actually you get a discount, right? So we think we use this terminology, you get a discount or you pay a premium when you are in the red area. So even if you don't want to sell it, then maybe do DCAs. We call it power law weighted DCA. So basically you're using this power law to give a weight to how much you want to buy Bitcoin. And also if you are in the green area, go all in. If you are in the yellow, just a little bit less. And as you go up and up, maybe stop buying, because you're going to get a much better price when you go back to the green area. So, we are trying to tailor it to different style of investments, and even just all this can even help you with your hodling and with your simple DCA.
Okay, thank you so much. This is completely
Yeah, this is
100% fascinating.
And I think we're gonna have to stop it there because I've got like a 2.5-hour drive to get to now. But
So,
no, this is amazing, and we've still got so many questions that I would love it if whenever, like in 3 months or whatnot, we have another
yeah,
chat.
so we can do it again. And if you join my
Definitely.
Patreon, we can talk all day long. We'll be there to answer any question, interact with people, help. Because I really want to create like a community of people that want to use this knowledge, and we can help each other. Because your questions also help me to think about this. So I really appreciate if you want to join our community, and we can continue to interact there. But let's do this again in a few months from now. Maybe check where we are relatively to the chart and so on.
And can I just before we end recording, can I just share something which I think
Sure.
a lot of people watching this on Twitter, YouTube, or whatever may find this handy. If I could share the screen, that would be great.
Yeah. What do I need to do to
I
get
will-
out?
there we
Stop
go.
share.
Does everyone see the PowerPoint with his Patreon?
Yes, we can.
So the thing which me and my community are always aware of is the total market cap. Because if you can accurately project what the total market cap may be, then you can have a better indication of what prices of other assets may be. So we've done lots of studies with percentage market share of lots of different crypto. So for example, if I just quickly get this out, 1 second. Sorry, I should have got it ready whilst here we go. So I've done this is just a little study of all the top sort of 20 coins in each cycle and what percentage market share they hit at various points. But long story short, of the ones that are in sort of the public domain, like the movers as I call it, and I'm excluding Bitcoin and ETH. So if you just take these, the average tends to be about 1.19% of the total market cap. So, however, some of the ones which really get going easily breeze past 2-3%. So one of the things I was trying to get my head around is that if the Bitcoin power law is accurate, and I think it will be accurate this cycle for sure, or not for sure, no one can say anything's for sure, but let's say it's 200k, which I think you said is like the mean line of your power law. So the next question that we have to ask ourselves is what is what's likely, what is Bitcoin likely to be in terms of market share? So historically, during the cycle highs, Bitcoin has been about 36% of the whole market. Then it was around 38. Now, personally, I think Bitcoin's going to lose a lot more market share this time around because there's way more crypto than before, yada, yada, yada. But I've just assumed 35%. So what I did on this chart here was that assuming Bitcoin has a 35% market share of the whole crypto market, and we hit 200k, that gives us a total market cap of 11.66 trillion. So then, all of a sudden, we can start doing some little calculations. Because, for example, what I've done in the Discord here is I've assumed, because I know the circulating supply of Casper, and I know the circulating supply of Tau by December 2025, which is what a lot of us here believe is going to be the next cycle high, because it's plus or minus 30 days from the 1st of December, typically. And then, unfortunately, I think it is unfortunate because we get some ridiculous answers. And when I say ridiculous, I mean batshit crazy stuff, because here is what I came up with. So I've assumed 2% market share. Let's say Kaz and Tau does do its thing. 2%, that means each one of them is $233.1 billion in market cap. And then I've just divided that obviously by the circulating supply at that date, December, etc. That gives crazy prices. So it's a 67x for Casper, 49 for Tau. But of course, like with anything, there are massive, massive ifs. So that's if total market cap hits that, and these projects are 2%. But here's the thing. Even if they hit like 0.1% of the market cap, that's still incredible returns. So yeah, like you know.
Well, remember, my model commits to only a 10 pair, right? I'm saying when it reaches $1, in 1.4 years. So this is what I'm predicting now. It's possible that, like I say, there is some deviations from that. So we could go to standard deviation up, but I'm not committing to 67 times. I'm committing to 10, and it will be interesting. And maybe it doesn't happen, but if this is what the model say, this is all what I'm saying. If the model continues to be true, we are going to have $1 CAS in mid 2025. Now, I think you're right to do these market cap calculations because they represent some kind of limit, and bring down some of our expectations and make it more realistic. But yeah, it's all speculations, right? So
thank you so much, Giovanni. Honestly, I cannot express how appreciative I am, and I think we are as a community. And yeah, I'll hopefully get this video out sort of Monday-ish because I'm away now for a couple of days. But thank you, and I think a lot of us will probably join your. I'm going to join your Patreon.
Thank you.
For sure. So.
Yes, thank you. Yes, thank you. Thank you.
It was nice to meet everybody, and even if I didn't have a chance to talk with you, but yeah, come to the Discord channel, and also join my Twitter, and we can continue the discussion there.
Amazing. Thank you, sir, and have a great day.
My pleasure.
In San Diego, my favorite city in the world, San Diego.
Yes, it's yeah.
Toodles.
Thank you.
Cheerio.
Bye.
Thanks, Gio.
Bye. Take care.
Right, let's end recording.